thank you. So let's come back to this example that I kind of briefly touched on. But remember the TX housing data set where we use that highlight key function to add some additional semantics to the data and essentially tell Plotly, whenever I trigger a highlight event, like a click, to filter the data that corresponds to this graphic, filter that data down to all the rows that correspond to this value of city. So that's why I'm able to do the highlighting with the raw data on the left-hand side, but then I can link that to an aggregated form of the data. And Plotly.js is actually, I'm sending all of the raw median values to this graphic on the right-hand side and letting Plotly compute, do the aggregation for me on the browser. So that's what allows me to essentially use this same system, the same framework for essentially filtering down to specific rows in the data, but then handing that off to the Plotly.js renderer and saying, here's new data, please do a new aggregation for me. So that's what allows me to have this probability density of the overall median house price for all of the cities. But then if I click on a specific city, then I can get a probability density just for that city. And then I can change the color here. So if I wanted to, say, compare the median probability density for multiple cities, I could do so this way. And here's the implementation. So at the very top, I use this highlight key function. For people who have seen these types of examples before, this highlight key is a very new wrapper that I've provided around this Crosstalk class called shared data. And I essentially provided it so that I didn't have to explain our 6 classes to people who are just seeing this for the first time. But you're essentially saying, okay, my unit of interest, if I interact with this graphic and I highlight something, I want to highlight things according to this city column. And then I go and create the raw time series via ggplot2, convert that to ggplotly, and control which aesthetics are being shown in the tooltip. Then for the aggregated part on the right-hand side, I'm mapping median to the x-axis. And using this, by default, when you use this tilde here, plot_lee works a lot like qplot in the sense that it's going to assume the value that you provide it is a data value, not like a visual attribute or like something on the visual range rather than the data range. So if you've ever seen qplot before in ggplot2, they work around this problem by using this capital I function. So if you don't want to map like a variable or like data values to a visual range and just provide the visual range directly to Plotly and say, I want everything black instead of blue or red or whatever it is, I can just provide color this capital I and then give it an R color, and that will translate to Plotly. And then to make sure that Plotly does a histogram with the probability density, I can do something like this and then feed that into a subplot so that I get the 2 plots on the same row next to each other. And notice here that I'm using this ability to control the attributes of the actual highlight when the highlight is being drawn. I'm setting some opacity of that additional trace that's being added to the graph so that there's some alpha transparency and I can compare multiple histograms at once. And as I mentioned sort of at the start, we also have the ability to use the same framework in conjunction with other HTML widgets. So this is going to work best if you're working with Leaflet or this package DT, which will be the next slide. But I can use the same highlight key function, and if you don't specify a column of interest, it will essentially take the row names or like just create, essentially think of creating like a new column where you have 1, 2, 3, 4, 5, just keeping like a row index for each row. And so if I create a scatter plot of the depth and magnitude of these different earthquakes here on the left-hand side with Plotly, and then with Leaflet, I could plot the locations of these earthquakes, which you can see is around Fiji and New Zealand. Now, if I say want to highlight all of the earthquakes that have greater than 5 magnitude and see where those are located, I could do something like this to essentially condition on magnitude 5 or higher, and then see what the geospatial distribution is that is linked to that. And as I mentioned, this highlight key function is really creating this shared data object from the Crosstalk library. And the Crosstalk library also has this pretty useful function, BS calls, which allows you to arrange multiple HTML widgets in a single standalone web page. So by default, it's going to put everything into, say, 2 columns if you give it 2 HTML widgets, but you can space these however you would like to. So here's how I could link Plotly to the DT package. And I'm also going to, in this example, load a useful data set from the MapView package, which you can, MapView is also a very awesome interactive mapping library that focuses just on mapping. So I'm going to load up the trails data set, use the highlight key function again, and this trails data set is actually an SF object where each row is going to correspond to a bike trail. So there's actually going to be multiple points being drawn for each row, but if I use the highlight key in this way, it will still know that I essentially want to, when I highlight something, I want to highlight that whole simple feature that's attached to that row. So if I go in and click on a specific bike trail, that entire trail is highlighted and the DT data table is filtered down to that specific row of interest, so I can see other information about that bike trail. And I'll point to my blog in the last slide that I have here, and I have a pretty recent post about, well, there's another post where I use this new geom.sf in ggplot2. So the brand new 3.0 version has this new geom called geom.sf, where it essentially automatically renders geospatial objects that are put into an SF data structure. So you can use geom.sf with Plotly as well. We already have support for converting geom.sf. And you can also provide SF objects directly to plot mapbox, plot underscore Lee, and there's also plot underscore geo. So there's actually 4 different ways you can use SF with Plotly. That's not on CRAN yet, but hopefully by like next week that'll be on CRAN. And I must make a note that you might be thinking, great, I can use Plotly with all these different HTML widgets and I can link them in all these great ways and I don't even have to use Shiny. But the truth of the matter is this is using again, the Crosstalk package sort of provides the glue between these different HTML widgets, and there's no guarantee that these other HTML widgets have gone on to add all of the additional functionality that the author of Crosstalk, Joe Chang, was initially thinking about. So some of these packages they might not support what I call persistent selection. It might just have transient selection, where when you make one selection and then make a new selection, that old selection is thrown away and just the new one is brought in. It might not respect like that color widget where you can change the coloring of the highlighting, or the this selectize argument. But all of these examples are actually just one class of events that is supported in this infrastructure that I like to call highlight or select events. There's a whole nother class of events called filter events. And these filter events should work, like they're more well-defined, so they should work better when you have multiple HTML widgets talking to each other. And with the highlight events, you dim the opacity of the existing markers and then bring in the new data that you've queried. But with the filter events, instead of dimming the opacity and keeping those essentially the data that you haven't selected, it completely removes sort of, the data that you haven't selected and brings in the new data and rescales the axes for you. And at least currently, we don't have a way to use direct manipulation to fire these filter events where you directly manipulate a graph. But Crosstalk provides a suite of different widgets that you can use to trigger these filter events. So here's a demo of the difference between the two. Here I'm using a Crosstalk filter widget to do filter events on the left-hand side here. And then on the right-hand side, I'm using the framework that we've talked about to do highlighting events. So notice how when I change the city here on the left-hand side, the y-axis scale automatically updates. And the cities that aren't in that drop-down are not being shown. But on the right-hand side, all the data is shown, and then I'm just highlighting specific cities. So here's an example of using the Crosstalk library, where I'm going to create a shared data object via this highlight key and feed that into these three different filter underscore select, filter underscore slider, filter underscore checkbox, and also specifying sort of like a unit of interest for these different filter widgets. So by saying filter select with the city variable, that will give me all the different unique values for the city column. And then for the filter slider, you should provide that a numeric variable like sales, and that will give me a slider ranging from the minimum to the maximum of that variable that I can then change in this way, and then a checkbox as well for year. So you could actually print that out and get a output like this, but on its own this isn't very useful. We should link that to an actual visual, and again I'm going to use that BS calls function and provide it the widgets so that I get sort of like a side panel with the three widgets on the left hand side, but then a plotly graph where I'm again showing the raw time series, but now I can use a filter event to sort of drill down to one city or multiple cities. And then I can also filter down on like sales and years. So let's have another exercise here. And this is really meant to sort of get you thinking about details that you might need to think about when you want to save these sort of results that are purely client-side, save it as an HTML file, and share it with one of your colleagues. So let's take about 4 to 5 minutes to do this one. Yeah, the second approach creates a much smaller HTML file, right? Why might that be the case? Exactly, yeah. So the first approach with the save widget, by default, it's going to inject all of the JavaScript dependencies in the HTML file. With the second approach, it's going to write those JavaScript dependencies to like external files, and then the HTML will reference those JavaScript files. So that's why if I were to use a save widget and give it just a basic Plotly graph, it will create this HTML file here, and that's almost 3 megabytes. That's because by default, the Plotly.js bundle is very heavy. It's like 2.2 megabytes for the full library. There is actually a way now, again, this is a non-CRAN, but it will be coming to CRAN, where you could reduce the size of the bundle by using this partial bundle function in Plotly, and this will try to find what we call a partial bundle of Plotly.js that has just the trace types that you need to render your graph. So if you're doing something pretty basic like a scatter plot or a bar chart, even a pie chart, this will be supported by like a much smaller bundle of Plotly.js. So if I did this instead, will take a second, but now I don't think it's that small. It gets down to under a megabyte. If you use this partial bundle function, it'll essentially crawl your Plotly object for you and try to minimize the size of the Plotly dependency. All right, but that's still going to inject Plotly.js directly into your HTML file, which is very convenient if you're trying to share this with your boss, just a quick one-off plot. If you want to send that to someone, this can be very convenient so that you just have to send them the one HTML file, and they can open it up in their web browser. They don't need anything else. They just need a web browser. They can open it and see your plot. But first of all, the save widget will only work for one HTML widget. So as soon as you move to a scenario where you have a collection of HTML widgets, or you want to use HTML tools in conjunction with HTML widgets, you'll have to use this save HTML from HTML tools. So here I'm going to save the results just to show you again. Here's my leaflet map, and this is going to be a collection of HTML widgets. And you can sort of check that by checking the class of these things. So P will be a Plotly HTML widget, and the map will be a leaflet HTML widget. But as soon as I want to combine these into something else, just call it X, where I have a collection of HTML widgets, it goes down to this lower level data structure called a shiny tag. And this is sort of the This really means that it's an HTML tools object. And I believe if you would look at something from Shiny, like a Shiny slider input, this would also be of the same class, but I should have had this done already. But if you wanted to create straight HTML from the HTML tools package, like create an A tag with HTML tools, that's a Shiny tag. So we're essentially now working with like this lower level data structure, and HTML tools will just consider this HTML content. So if I provide this to save HTML, it's a similar interface where I provide it, you know, the object that I want to save, and we'll do leaflet, name this leaflet Plotly. And now if I look at this HTML file, this file is very small. And if you look at the source code behind it, it's actually for the JavaScript dependencies, instead of bringing in the JavaScript file into the HTML, it's going to reference a file that lives on my file system. So this is actually, when you open this HTML file, your browser will look on your file system for this folder here, the lib, and go into HTML widgets, find this JavaScript file, and basically import all of that file and render it in your browser. So this is going to be much more useful to you if you're doing a larger project, like, for instance, my slides. I'll show you how I created my slides. I essentially, hopefully, we'll actually work out better solutions for this in the future, but essentially what I do is create these HTML files that are very small. They're all referencing JavaScript files that are all located under one folder. So all these HTML files, oh, I didn't mean to do that. So all of these files are referencing this index files folder, where now I can have all of these HTML files that my browser doesn't have to do as much work, where if you're embedding the JavaScript in each one of these independent HTML files, your browser would have to parse and download and parse the same dependency maybe 30 or 40 times over. So that's a scenario where you would end up with a very sluggish slide deck, which I used to do years ago, but then I sort of moved to this workflow where I have just one folder that contains all the dependencies I need, and then have multiple HTML files that can reference that same file, so your browser does less work. All right, so here's a little diagram I just came up with quickly the other night. But you could kind of think of this as like a hierarchy where HTML tools is kind of sitting at the lowest level, where there's lots of R packages that build on top of this functionality. So even things like Shiny, which we'll get to eventually, this is going to require an R server, but it's also using HTML tools to build the user interfaces that you see. And the same thing is true for HTML widgets, even Crosstalk and Flex Dashboard, other libraries that create client-side content are pretty much all of them, or at least, you know, if you're using an RStudio package, you can be guaranteed that this will be the case, or if you're using an HTML widgets package, it's guaranteed to be the case that really underneath all of the functionality there, at the end of the day, you're working with an HTML tools object. So that is one of the three main ways to approach adding, some more advanced reactivity in your Plotly graphs beyond just like hovering on stuff in your graph and zooming in on particular regions. Plotly.js also has the ability to create what you might want to call native sliders or native drop-downs or buttons, where when a user interacts with a slider or a button, you could actually use a Plotly.js function to modify your graph. So to give you just one quick example, I'm not going to spend much time on this because there's a lot of detail to it. But here's just a basic example where I have a drop-down where I should fix the sizing on this, but this will change the base layer of the Mapbox map that is being used as like a base layer for this Plotly graph. And then, if I switch this to satellite, then I could actually get real up close and personal. And, basically see someone's house if I wanted to. But these are all the sort of default Mapbox themes that are bundled with Plotly.js. You can, with Mapbox, style your own base layers. But just in this example, I've sort of provided the base options that are provided for you. So the implementation is actually taking advantage of this schema that I mentioned a while ago. This contains all of the Plotly.js specification. And I can actually reach into that and grab all of the valid values that I can provide to the Mapbox styling. And then I'm going to use basically loop over all of the styles and create a list for each style, which will define a button that will go into this dropdown. So this lapply statement here will create a list of lists. And each sort of list component here will have a label for the button, and then it's calling Plotly.js's relayout method. So this is a way of using the JavaScript library of Plotly.js to say, just restyle the Mapbox layer, or just rescale the y-axes, or just rescale the x-axes, or maybe just add a title. So we're going to be working with Plotly.js, both like, this is sort of my introduction to Plotly.js, but we'll be using it with Shiny as well, because we can leverage the Plotly.js interface to, make more efficient updates to our graph rather than having to redraw everything in the graph every time we need an update. We can just target very specific things in the graph to update. And then I can use plot Mapbox in this way to create the actual visualization. And I have links here, this link on sliders and buttons and drop-downs. These are links to our online documentation. If this seems like something that you might want to use, we have some code examples up online. But I also want to give you a little bit of insight into using custom JavaScript via this onRender function from HTML widgets. So generally speaking, this onRender function is a way to define a JavaScript callback that is executed when your widget renders. And what this means is that I can provide some custom JavaScript to, say, respond to a Plotly.js event and do something custom with it. So we'll be using this to respond to a click event, to maybe add an annotation to a graph, or some other things. Yes, so this is an example where you could leverage onRender to say, open up a Google search when I click on a point. So here, when I click on a point, this is tied to different cars in the MT cars data set. And when I click on a point, it'll open up a Google search to look up that specific car. So the way that I do this is you can leverage this custom data attribute, which is a way of attaching like some meta information to a graphical object in Plotly.js. So I'm essentially attaching this string with this Google search query to each point, and then using onRender to say whenever I click on a marker, access the event data attached to that click event, and strip off the custom data from that this custom data attribute from that event data, and then make the browser open up a new tab pointing to that URL. So I've done this, actually, some applications for like volcano plots if you're into bioinformatics, that when you click on, say, an interesting marker, this would look up a particular gene in a gene database that lives online where you could get more information. And I also have, if you'd like to work from the cloud project, this is really going to be the only way that I've provided this script to you. So hopefully you're able to access it. But I also have it locally. Or do I? I don't have it locally. So we're going to be working from this custom data script, and you can open up that script by running this R code here on the cloud instance if you'd like to follow along with me. But there won't really be any exercises in this part. It's just if you'd like to follow along. So I'll do that. So a similar example here where we're really creating the same visualization by default, but we're going to be playing with different JavaScript callbacks to this visualization. So I'm still assigning this Google search query to the custom data attribute here. And if I were just to print this, come on. Now if I click, nothing happens if I click on these points because I haven't defined like this JavaScript callback that would open a browser or do something else with this custom data. In this first part here, where did you go? Yeah, so this is how we could do this same example. I've just provided it in a separate JavaScript file so that I can open up in RStudio and have the nice syntax highlighting to show you a little bit better how this code looks. And I guess I didn't explain this, but this function that you provide to onRender, it has two arguments. The first argument is the what's called a DOM element container, which holds your HTML widget. So this EL argument contains this DOM element, and that element has a method called on. So I can use that method to say, on a Plotly click event, please execute this function. And I'm not using this second argument, but this would potentially be useful in the sense that this is the data that's being provided to the HTML widget on the client side. So now if I run this, this is just kind of a more convenient way to bring in a JavaScript file that's in an external file. And I get the same result as in those slides, where now if I click on a point, I'll get this Google search query. But I could change that slightly and again listen to a Plotly click event and grab the custom data from that marker that I've clicked, feed that into a JSON object, which will define an annotation that I'll put on the graph. And let's just have a look at what it does first, and then I'll explain. So now if I click on a point, this will add an annotation to the graph with a hyperlink to that Google search query. So now it doesn't open it up by default, but I can still get at the link and click on it that way. So I do that by using this relayout method, which we are using the relayout method to have that drop down where I was changing the Mapbox base layer. But this is how you would leverage that method in pure JavaScript, where I'm relaying out the relevant DOM element and adding to the annotations attribute. And here is the definition for what text should be shown in that annotation and where it should be placed, and so on and so forth. And notice that you can also supply HTML content to these annotations. So that's why I get the blue hyperlink here, is because I'm using an HTML hyperlink. I could do essentially the same thing, but instead of listening to a Plotly click event, we could listen to a Plotly hover, and the rest of the code is the same, but now as I hover, then the annotation will be updated. And I think this becomes even more powerful when you can use it in conjunction with the highlight key API that I've been talking about before. So here, I'm making it so that when I click on a point, not only is the annotation being drawn, but I also get the hyperlink down at the bottom. So I've used this to, say, hover on a spaghetti plot where you have lots and lots of lines, and you want to hover and say, by hovering on a specific line, you want to highlight that line, so I would use this highlight key interface to do that, but then print some more meta information about that specific line, maybe as a subtitle. So, and if you're new to, creating stuff on the web, it can be useful to know about your browser's developer tools. So if I open up this graph in a new tab and right-click on the plot and go to this inspect, this will be slightly different if you're in Firefox or Internet Explorer or some other browser. But if you right-click and go to inspect on Chrome, this will open up Chrome's developer tools. And if you wanted to, you could actually see the HTML and SVG content that goes into a Plotly graph, but that's going to be really big and complicated. The point of this exercise is to let you know how you can use your console. This is a JavaScript console where I could test how certain JavaScript code works. But I've also designed this example. If you look at this inspect events JavaScript file, this is adding listeners for some common Plotly events and just printing out the event data that's attached to each one of these events. So by using this console log in JavaScript, when this event is fired, I will see the relevant information in my browser's developer tools. So now when I hover, new data is being printed. When I click, that information is being printed. If I click and drag to zoom in on a specific region, I can get at the X and Y axis range of that event. So you could listen to this event and say, like, have another view attached or listening to this event. And then there's also, I've actually had a couple questions about this, but by default, the behavior for a click and drag in Plotly is to zoom. So that's why by default, I get this behavior. But if you wanted to change that to a rectangular or lasso selection, you could click this box select to do a rectangular selection. And then when I click and drag and select points, the 8 points that I've selected, I would get all the information about those points in this event data. And this will also work for lassos. And you can also get information about, well, maybe not. Yeah, you get at the pieces of information that you're most interested in, which is these actual points that you've lassoed. There's one other thing I wanted to mention. I forgot. But yeah, so if you're willing to work on the JavaScript level, these are all useful things to know about, especially just being able to listen to these events. And I think at some point, maybe I didn't, but if you Google for Plotly JavaScript events, you should find this Plotly.js events documentation, where this will have even more examples of how you could respond to Plotly events in pure JavaScript. All right. I thought I had a slide where I wanted to go back to, this diagram. Where now we're going to move from this point of I'm sort of done showing you what Plotly can do in a standalone web page, but now let's go back and consider throwing a web application into the mix. So if you'd like to follow along with me, you can run this Shiny app that I'm going to use as sort of like a Hello Shiny example. Good. I'll just run this locally. So this is very similar to what we've already seen with the filter events, where I'm just going to show you how you could essentially create the same thing with Shiny, so, just so that we can get started looking at some Plotly examples. So I programmed this so that every time I add a new city to this dropdown, I draw the time series for that city. And if you look at the code here, I'm using a selectize. Well, let me step back and, for anybody who's not familiar with Shiny, explain that there's two main components to a Shiny app, one being the user interface definition, and that's this part here, and then the server logic. So the UI will sort of lay out all of the views in your web page, and then the server logic will define like what widget responds to another widget. So in this user interface, I'm just providing two different things in this Shiny app. The selectize input, which creates the drop-down with all the different unique cities here. And I'm attaching an ID to this input called cities. And by default, I'm going to make that value equal to Abilene. And then the other component to this web page is going to be some sort of Plotly output, which is attached to an ID of P. And that ID, notice how it matches up with this ID here on the server logic, meaning that whatever is the result of this render Plotly statement, it's going to inject it into that Plotly output container. And the render Plotly is needed in order to be able to essentially access the input values on the server, and then also make sure that Shiny knows that I'm outputting a Plotly object in this reactive statement. And here I'm actually using Plotly's ability to work with dplyr verbs, in the sense that if you provide a data frame to Plotly, you can think of that Plotly object as being like attached to that data set, and then you can actually manipulate or modify the data behind the Plotly object by using dplyr verbs on that Plotly object. So here I'm starting out and just like initiating my Plotly graph with the TX housing data set and these two variable mappings, and then filtering down the data to just the cities that are in this input cities widget. And then grouping by city to make sure that I get one line per city, and creating the time series. So every time I change this, all of that R code is being re-executed. And Shiny by default, even with HTML widgets, is going to do a full redraw every time I change this value. Even though it looks like I'm just adding one line, the entire plot is being redrawn. The DOM element is being purged, and a new DOM element is being put in, and Plotly.js is going through the same routines over and over to create your plot. But since there's not a whole lot of work to do, it looks pretty seamless. But if you were working with lots and lots of data and just needed to add one line, and there was lots of work to do to get there, you would notice there'd be a noticeable lag. All right. So what about accessing some of these user events that I just showed you how to access with JavaScript? That's the point of this second Shiny app here. Where this is a Plotly graph that I've created via ggplotly, but this could be Plotly as well. Where I think I'm just listening to Plotly selected events, which work for the rectangular selection, as well as the lasso selection. So Plotly selected means that I've clicked and dragged and drawn some sort of region to select a number of markers in this case. So here I've used ggplotly and made sure by default when I click and drag it will be a rectangular selection like this. And then using this event data function, which comes from the Plotly package and is designed to make it easier for you to get at the event data information on a Shiny server. So you can think of this, it basically boils down to a Shiny input value. So you could think of this as almost like, if you're familiar with leaflets, you can do a similar thing where you can listen to user events on a leaflet map by saying like input $map ID $something else. So this is a lot like that API, just designed a bit differently. Let's see. Yeah, so I will take just a couple minutes, maybe just 3 minutes instead of 5, and see if you can't change that last app to use plot_ly instead of ggplotly and print out information for these other input events. I don't want to spend too much time on this exercise because I think there are some better ones. But I also want to point out that, we saw how to run a demo in R, and if you notice when you ran that demo, your R console echoed the code that was necessary to run that example. If you go to our GitHub page, ropensci/plotly, you can find all the source code that makes the R package work. And there's a demo folder, and this is like a standard place to put demos for an R package. And you can get at all of the source code for these demos, so if you wanted to maybe have a little bit better of an interface for looking at that code, you could go to this link here, and this was the demo that generated that English Premier League visualization. So you can get at all the different demos this way. But there are also some Shiny and R Markdown examples that I ship with the package that don't really make sense to run as a demo. So it can be useful to know where to find these on GitHub. And they're under this inst folder. So if you're not familiar with how an R package works, whenever an R package needs to include other files that are not under these other standard directories like R or data or demo, there's this inst folder for just basically copying files over to the installed package. So all of these files are available in the installed package as well. And there's an examples folder here where I have both Shiny and our Markdown examples. So there's actually some R code, I think it's run examples, where you can run these examples, but I also want to show you how to get at them on GitHub. You can go under this inst examples and then Shiny, and then there's a handful of different Shiny examples. And there's actually this events data app that essentially does what the exercise was asking for. So let me copy that over and run this. So this is basically designed to show you the different event data that you can get at with both ggplotly and plotly. And notice here in this example as well, there's another column that I'm getting that in addition to the second example that I ran initially. There's also a key column here, and this is basically so that I can, by just having the X and Y values, there's no guarantee that I know exactly what row in this data set this point pertains to. So you want to attach like a unique key identifier to your data and be able to access that in Shiny. So I showed you how to do this with custom data, which is more of like a Plotly JavaScript way of doing this. But I also want to point out that this is possible with Shiny by using, we'll also sort of relay information from this key aesthetic in ggplot. So if you use this key aesthetic in ggplot, you can access that variable or that column in your data set through the event data. And you can do the same thing with plot_ly. And then here are, you could just repeat this render print statement to essentially just echo whatever the event data is for these different events. All right, I might come back to this one, but I want to make sure that we get to these last two examples. And as I mentioned, by default, when Shiny updates something, it's going to basically do a full redraw of that thing. But one of the benefits of working with web-based content like HTML widgets, instead of like a static graphic that's generated from your R graphics device, is we can target very specific things in that visualization to update rather than doing a full redraw. So this is going to make, we're going to be able to do this via something that I call Plotly Proxies. And this is, very much, it's basically, I got the idea and the interface design directly from Leaflet, which was the first to implement this idea. So you could do something very similar with Leaflet, and also DT has some support for this as well. A real sort of basic example here where this drop-down is just going to control the fill color of Canada. So when I change here, notice how there's almost like a smooth transition from the previous color to a new color. and the map is not being redrawn. The polygon outline is not being redrawn. It's just the gradient that's changing of this fill color. So in order to do this, I'm going to make use of this Plotly proxy function, where here this is the sort of the initial draw, the definition of the initial draw for the map. So don't worry too much about what's happening there. Just notice that for this dropdown, I provided all the valid R colors to this dropdown and attached the value of this input to this ID of color. And then I'm using this observe event function in Shiny, where this is a way of saying whenever the value of this input changes, please re-execute this R code. So every time I change this dropdown, this code below here, these two lines, will be rerun. So the Plotly proxy needs to reference the actual output ID. Essentially, it needs to know what elements on the web page or what Plotly graph am I going to be modifying. So that's why I have the map here, is this is referencing this output ID here. So at that point, well really at this point, this has created like a proxy object where I now know that I'm going to be referencing this map ID output. And then you can chain multiple Plotly.js functions if you'd like to, but here I just need a restyle event. The restyle is like relayout, but restyle is for the data that's in the graphic, not like the layout definition. So the restyle is going to be useful for changing the fill color. You could use it to change the colors of like the outline of the polygon, or the color of markers, or even the positions, anything that's related to the data or the trace. And here I'm just supplying the input color. We have a little 2RGB helper in Plotly to essentially take like an R color code and translate that to an RGB color with some alpha blending optionally, so that it fits the Plotly.js format. So yeah, that's a way of just making sure that I restyle the fill color of the map. And I could do a similar thing for streaming data. Let me show you this one. So by default, there's just basically 2 points being drawn here at 1, 0 and 2, 1. But then I could hit this button to, you don't have to do it this way, but what's happening in this graph is I believe every 100 milliseconds, I go back to the Shiny server, sample either, randomly sample either a -1 or a 1, and then add that to the most recent Y value. So this button is basically keeping track of whether we're in a streaming state or not. I could turn it off by pressing it again, but then turn it back on to turn the streaming back on. And this is going to make use of some fairly sophisticated Shiny code, and I'll try to walk through it fairly quickly so you can get a rough idea of how something like this would work. But again, a simple user interface, just 2 widgets here, action button that I can access through the input $stream, and then the Plotly container. I set some initial values for the y values, and then essentially just do that initial draw of the plotly graph where I have those 2 points at 1, 0 and 2, 1. And if you use Shiny a lot and haven't heard of reactive values, I suggest you have a look at it. I find it quite useful for doing something called maintaining state. You can almost think of it like if you're already used to working with input values a lot, this is a way of almost like creating an input value on the server on the fly that isn't directly attached to like a widget on your web page. So by default, I'm just going to create these reactive values. One that will keep track of the stream here, the first one, is going to keep track of whether we're in a streaming state or not. This y end is going to keep track of like the most recent y value that I have in my stream, and the n will keep track of how many data points are in my stream. And then every time the stream button is pressed, there are different ways to do this, and ignore this part. This is more for debugging than anything. All I'm going to do is check whether, is this reactive value of stream, are we currently streaming? If we are currently streaming, then I want to turn it off. If we're not currently streaming, then I want to turn it on. So every time the button is pressed, I'm essentially updating this reactive value of stream. And then in this observe block, observe is a lot like render print or render plotly or render whatever, but with those render statements, it's expecting a return value, where with observe, I can just run some R code without returning anything. So with this observe block, I can first check whether or not we're streaming. If we're not streaming, then I'm not going to do anything. I'm just going to exit early, and there's nothing to do. At this point, I'm going to make use of this invalidate later in Shiny, which is a way of saying invalidate this chunk of R code every 100 milliseconds. So this will make sure that I reach this point, or I make a callback to the server every 100 milliseconds. And at this point, I guess there's different ways you could do this, but here I'm accessing the number of points that are currently in the stream and adding one and overwriting that reactive value. Since I'm overwriting that reactive value, I would actually get stuck in a loop. This is sort of how Shiny works, where if I reach this point, Shiny would say, oh, this reactive value n has been invalidated. I need to go back to the beginning and re-execute. But you can use this isolate function to prevent that from happening. So here I'm just adding 1 to the number of values in my stream, adding randomly sampling a -1 or a 1 to add to the most recent y point, and then using plotly proxy again to just basically add 1 point to that line. You could probably, like this example would probably, at least in the very beginning, you wouldn't be able to tell much of a difference whether you were doing a full redraw or just adding 1 point. But if you're dealing with lots and lots of data, if you let this run for a long time, then you would certainly notice a glitch or a lag if you're doing a full redraw every time. But here we're just adding 1 point via this. There's another Plotly.js function called extend traces, where it's a way of essentially adding 1 or multiple points to an existing trace. So I have this exercise. If you'd like to complete this, please feel free to. But I think I'll leave it a little bit more open-ended than that, since we really only have 3 minutes. Either do this your turn, or maybe try to think about how you might implement that idea that we had at the very beginning of asking a question of your own data, and I'd be happy to come around and chat with people and see if I can refine your thinking a bit. But thanks so much for coming. It's been really awesome to be here. Hope to see you guys around the next few days. Thanks.